Welcome to the webinar this afternoon about the Globe Trees Challenge 2020, Make Every Tree Count. My name is Kristen Weaver and I'm the Deputy Coordinator for the Globe Observer Project. First, I'd like to give you just a bit of an overview about what we're going to be discussing over the next 90 minutes. This webinar will also be recorded and made available on our website if you aren't able to stay for the full time or wish to review individual segments later. For our agenda today, after this introduction, we will hear briefly from two different scientists, Nancy Glenn and Amy Neuenschwander, about the importance of tree height observations in their research and how your observations during the challenge can support scientific understanding. Next, Brian Campbell, our Trees tool lead, will walk you through how to actually use the app to make measurements. Then, Holli Kohl, the Globe Observer Project Coordinator, will explain what Globe teams are and how to use them during the challenge. Heather Mortimer, our graphic designer and science writer, will walk you through a few important sections of the Globe Observer website, especially the Toolkit for Informal Educators, and show some highlighted resources for the challenge. After that, we will get a few examples of how the Trees tool can be used in informal education settings from Brittany Blomquist at the LaSalle Public Library and Tasia Owen on our Globe Observer Communications team, who has led events with Girl Scouts. Finally, we will have a period of Q&A to allow you to get your questions answered. And again, because I know there is a lot of information about to be presented, this will all be available afterward on our website. To begin with, I'd like to offer one of many definitions of citizen science for those who may not be as familiar. In the paper, Citizen Science, Can Volunteers Do Real Research?, J.P. Cohn defined citizen science as a form of research collaboration involving members of the public in scientific research projects to address real-world problems. I think some of the keys here are that it is real science being done in a voluntary way by people who are not professionally trained scientists, but are contributing to research. In fact, one of the other terms often used for the concept is public participation in scientific research, or PPSR. There are varying levels of engagement by volunteers. It can be strictly data collection for an existing project, crowdsourced analysis of data, or in some cases, the citizen scientists can be involved from the very beginning in developing the project and the research questions. You may also hear community science used as an alternative to the word citizen. You know your audiences and what will resonate best with them. The Globe Observer Project is rooted in the GLOBE program, a long-standing citizen science project that started out primarily training teachers to do data collection and analysis with their students. In the U.S., GLOBE is sponsored by NASA and supported by the National Oceanic and Atmospheric Administration, the National Science Foundation, and the State Department. You can see some of the stats here. Started in 1995, an international program in 122 countries, over 175 million measurements reported. It was actually about 178 million when I checked the website yesterday. For the full GLOBE program, the data covers a wide variety of topics, including over 50 data collection protocols, although of course we are focusing on just trees for today and for the challenge. In 2016, the Globe Observer app was released, which expanded the accessibility of the GLOBE program to a much wider audience, including the interested public who received their training through the app. We chose a subset of GLOBE data collection types that didn't require much equipment beyond the app itself and would be enhanced by the technological capabilities in smartphones, sensors, cameras, GPS, etc. We started with clouds and, as you can see, have expanded to mosquito habitat mapper, land cover, and trees, our most recent. So, with that background, to get to the main purpose for today, the Trees Challenge 2020, Make Every Tree Count. As you probably saw in whatever announcement led you to this webinar, this year marks the 50th anniversary of Earth Day, as well as the 25th anniversary of the GLOBE program. Rather than limiting ourselves to a single day, though, we are inviting volunteers to measure the height of trees throughout the month of April, contributing observations of as many different trees as possible. Participants can be individuals, compete as a team, or be part of a GLOBE school. We will get to more about teams later, but since this webinar is focused more on informal education settings, we won't be covering school participation. We do have more information about that on the challenge website, and always feel free to contact us with any questions. Top observers in each category will be recognized on our website and social media and will receive a digital certificate. So next up, we are going to hear from some scientists about why this is important and why it actually matters to collect this data. So we have two different scientists who are part of the ISAT satellite team, ISAT-2 satellite team, excuse me, and they will introduce themselves on as part of their presentation.
Hey everybody, my name is Nancy Glenn, and I'm going to talk today about why we should measure tree height. I'd like to acknowledge the contribution from all of my students. And I am from the University of New South Wales, recently arrived from Boise State University, where a lot of this research has taken place. So a little bit about me. I'm an engineer by training, but I've always loved landscapes, and I've been fascinated by how our landscapes are changing. I have a family of 2 children, and my husband and I have always tortured them with Nordic skiing in the mountains, but now they're happy to be at the beach with us in Australia. So one of the studies in which we measure tree height is a Department of Energy spruce study, where a group of scientists are very interested in how increased temperature and increased CO2 may be changing the vegetation. So we're there measuring tree height because it's an indicator of the environment. And so in this plot, you see very detailed measurements of trees that we're making. But just really general tree height measurements can be super helpful to us, and that's where we're hoping that you'll be able to contribute. So we make these detailed measurements with a terrestrial laser scanner, and it looks like this 3D point cloud over on the right-hand side and in the previous slide. And from those measurements, we track how the trees are changing with time with these increased temperatures and CO2 from these plots. But we're upscaling that with NASA assets, airborne as well as satellite-based measurements. And the more tree heights, the better. Another reason why tree height is really important is that it affects snow depth and extent. And this is a study that we have with NASA called SnowX. It's taking place in Colorado as well as in Idaho. And tree height's important because trees can actually intercept snow, but then they can also provide shading, which may cause differences in snow accumulation as well as snow melt. So if we're interested in how much snow is there and ultimately how much water do we have in that snow, we need to know something about the trees. So we're measuring tree height, again, with a very detailed terrestrial laser scanning machine that you see over there on the left with a colleague and I collecting data in the field. But ultimately, more tree height measurements from around the globe, especially in areas where there is snow accumulation, we're very interested in because we would like to upscale these to the landscape scale. And so we're doing this, again, in Colorado and Idaho using airborne as well as NASA satellite measurements. The plot over on the right shows a group of trees, and then all of these colors here are snow depths. And so you can see there's a lot of variability in snow depth depending on where the trees are positioned, and in this case, also where wind and topography influence snow depth. So trees certainly have an influence on that snow that we're interested in. Another study that's very similar is a study in the Reynolds Creek Experimental Watershed, which is a watershed managed by the USDA Ag Research Service. And we're working with a number of partners here. This is a critical zone observatory. NEON is helping us, and as well as this is a NASA funded study where we're very interested in how tree diversity across this watershed changes. So tree height affects streams. So if you think of about a riparian corridor, tree height provides shade to those streams, and that can affect temperatures. And that's really important in dryland environments where we have perennial streams. They're not there all year long. So what we're doing in the Reynolds Creek Experimental Watershed is we're measuring tree height because we're interested in biomass, how much tree is there, and the carbon associated with it, but we're also really interested in the structural diversity. So the variation in the trees in the vertical direction, as well as the horizontal direction, is really important for habitat. So we're making these measurements on the ground, we're making them from NASA airborne data, and then we're upscaling them and we're testing them with NASA satellite-based measurements like ICESat-2, as well as JEDI on the space station. So what I want to leave you with is that what is the fate of our trees? If we're going back to thinking about how the landscapes are changing across time, and I've just arrived here in Australia, and there's these massive fires that have occurred here for the last few months. We have these beautiful landscapes with all this diversity that have been decimated. And we really need tree height measurements to understand how the landscapes have been disturbed, but also how are they going to recover? And so this is a call out to you to measure more tree heights, especially in Australia. Brian was kind enough to send me this image of some of the existing tree heights that we have, but we need more. So whether you're in North America, Asia, Africa, Europe, Australia, anywhere across the globe, we're hoping that these tree height measurements that you make could then be used in the studies like what I described. And the way that they're going to be used is by augmenting the existing data that we have so that we can upscale from our plot data all the way up to landscape so we can really track how those landscapes have been disturbed. Thank you.
So we have our second scientist coming up next, Amy Neuenschwander.
My name is Dr. Amy Neuenschwander, and I'm a research scientist at the Applied Research Laboratories at the University of Texas at Austin. My research is focused on using remotely sensed data to better understand the structure of forests. Since 2010, I've been working with NASA on a new satellite called ISAT-2, which uses a photon counting laser to map the heights of the surface. ISAT-2 launched in 2018, and thus far it has collected billions of photons to this point. So why do we care about tree height? Trees play a critical role to the health of the earth through the absorption of carbon dioxide during the photosynthesis process. Trees store carbon dioxide and use it to build and grow itself in the form of trunk, branches, and stems, etc. Since we know that carbon dioxide is a key factor to the warming of the atmosphere, one of the parameters that scientists need to better understand is how much carbon or biomass is essentially stored in trees. So essentially, how heavy is a tree? So knowing the amount of biomass information lets scientists make predictions and models about global climate and climate change. So biomass is estimated by using models of tree height and other height parameters that we can derive from space-based LiDAR. So as I mentioned, I've been working on the NASA ISAT-2 mission since it began the development in 2010. The satellite actually launched in September of 2018, and since it's been in orbit, thus far it's collected over billions of photons and laser shots going out. So the laser is actually split into 6 laser beams. They're configured into 3 beam pairs on the surface of the Earth, and each beam pair is roughly 3 kilometers apart on the surface. So the laser is firing at 10,000 pulses per second, which gets us really high resolution detail in the direction that the satellite is recording the data from. So with this data over time, we can start to build a full understanding of the Earth's surface heights and the tree heights globally. So I work on the ISAT-2 mission, and I'm working primarily on the algorithm that produces the tree heights and the terrain estimates. As I mentioned, ISAT-2 is a laser altimeter that sends a pulse of light energy to the surface, and reflected photons from the surface are detected by the satellite. So here's an example of what ISAT-2 data really look like. This is an example of a profile of ISAT-2 data over a boreal forest in northern Alberta, Canada. So the top panel is what the photon counting data look like. You can see the photons of the trees and the ground, as well as the photons below and above the surface. So part of my job over the past 2 years has been focused on writing the software that determines which photons correspond to the ground and which ones are from the trees. Once they're labeled, we can then calculate tree height. And what makes satellite data such a powerful tool is that we can map forests everywhere and provide estimates of tree heights across the globe. This capability is so critical because the process of collecting field data by scientists is extremely labor-intensive and can be costly. A role that citizen science can play in my research is the validation piece of the ISAT-2 data products. That is, do the heights that we see from ISAT-2 agree with what people are collecting with the GLOBE application? The accuracy of the validation data, though, is extremely important. If the validation data are not accurate, then we will not know how well or poorly ISAT-2 is mapping tree heights.
Okay, so that gives you a little bit about what the scientist background, what they're interested in, why this data is important. But so the next question is, okay, this is why it matters. But next, we're going to have Brian Campbell, our trees lead down at the Wallops Flight Facility in Virginia, and he is going to share a little bit about how to actually use the app and give us an example measurement so that you know what is going to be required of you as part of this challenge.
The NASA Globe Observer Trees tool is a fun and exciting way to measure tree height by just using your mobile device. But before you can take any observations of tree height, you need to complete the introduction and the tutorial sections of the app. So Starting off with the introduction. If you go into the NASA Globe Observer and you go to the Trees tool, you can go to the introduction. So it's going to welcome you to the app and basically discuss why recording tree height can help and what are the benefits of it. You can track how trees are changing over time and can help estimate the number of trees that make up an area. And there are NASA missions and instruments that are also able to measure the height of trees from space. So the tool guides you through steps to estimate a tree's height. And there are 4 major steps here, and we're going to go through those in a little more detail. So before you begin anything with the observations, you have to choose what your preferred system of measurement is, whether metric or English. And when you do that, when you make that selection, it will take you to the next screen where you are to put in your setup information, primarily your height. Your height is very important because you're going to be using your phone's camera to measure the angles to the base of the tree and to the top of the tree. And by knowing your height, the app will estimate your average stride length and the height of your phone at eye level. That is very important for taking tree height observations. Once you input that information, there are some links here that take you to some other things you can learn about tree height and about how NASA measures tree height from space and other options as well. So after the introduction, you'll be prompted to review the tutorial on the app. And the tutorial section is vital because it runs you through the steps needed in order to complete the tree height observation successfully. So always remember that you have to do this first before you're able to take a tree height observation. So a couple things to consider when selecting a tree. The tree should be over 5 meters tall, and when possible, take measurements of isolated trees or groups of trees. And if you have a group of trees, the tallest tree in that is very important as well. So when you select a tree, you want to make sure that you're able to safely see and access the base of the tree and the top of the tree. Meaning, if you're able to view the base of the tree and the top of the tree, and you're able to walk to the base of the tree, that's ideal. You want to be about 7 to 25 meters or 25 to 75 feet away from the base of the tree to do your observation. Now, the most important part of the tree height tool when taking tree height observations is measuring angles. You will see in this little clip that she is holding the phone at eye level. So wherever your camera is on your phone, that has to be at eye level at all times when you're looking at the base of the tree and the top of the tree. And, ideally when you're taking a photo of the tree. Because what's happening here is that you are measuring the angle from your eye level to the base of the tree and to the top of the tree. And what your phone's doing with its built-in instrument, what it's doing is it's measuring those angles. And if you keep the angle consistently at your eye level, because that is the app estimated your eye level based on your height, you don't want to change that angle of which you're holding your phone, meaning you don't want to raise your hand and arm up to look at the top of the tree and raise it down to look at the bottom of the tree, because that will change the angle of how you're viewing the top and the bottom of the tree. And therefore that will change the height of the tree. So you will get an erroneous tree height observation if you're changing the angles and not keeping the phone at eye level. As you can see, she is just bending her hand and wrist and not moving her arms up and down, her arm up and down. So here, we measure the angle to the base of the tree, and then we measure to the top of the tree. And then after we take the angles, remember, keeping it at eye level all the time. After you measure the angles, you will then be prompted to take a photograph of the tree. And that will remain with your tree height observations on the Globe database for reference purposes. Now, based upon your height, the app calculates your stride. So now after you take the tree photo, the app will ask you to walk to the trees counting your step. The most important thing here is that you use a natural stride, meaning that you don't want to separate your steps with too much space or too little space. So just walk normally to the base of the tree, counting your steps. And once you get there, you're going to be asked to enter how many steps it took to get to the tree. So with all that information combined, the measurement of the angle to the top of the tree, to the bottom of the tree, and the number of steps towards the tree that you walked, all those and the trigonometry involved will allow the app to estimate the height of the tree. Now, one thing I want to mention is that we understand that it can be difficult to walk on a natural stride, with a natural stride to the base of the tree if you are on a hill. Meaning, if you are walking downhill to get to the base of the tree, or you're walking uphill to the base of the tree, we know that your natural stride will be very hard to accomplish. So your steps might be closer together, or they might be further apart. So there's a spot on the app in the review section where you can actually change some information. And there's one box called distance to tree. So what we recommend is, if you're on a slope having to walk downhill or uphill to the base of the tree, we ask you to take a tape measure and measure the actual distance from where you took the observation to the base of the tree, because that will allow us to have that exact distance. And with that information and those angles that you measured previously with your phone, the app is also able to estimate the height of the tree. So here's a couple things about testing for accuracy: checking your location, make sure you're standing basically under the tallest point of the tree, but that should be directly above the base. So if you have a curved tree, the angles that you measure to the tree, to the base of the tree and to the top of the tree won't be at the same location. So the tree height will be off as well. So it's super important to check your location. Now you want to make sure you do this all safely, and you adhere to all local laws and regulations and private property information. So you want to make sure you do all this safely. Now, when you're next to the tree, once you walk to the tree, count your steps and put that information in, it's going to ask you basically, where is the tree? And it will estimate the latitude and longitude of where the tree is. And then it will also give you a map that you can see where your tree is on the map. And I'll show you that in a little bit when we take the tree observation. So once you get all this information, success. You have now measured the height of the tree. There are a couple more slides here on the tutorial. One here is measure your tree circumference, which is an optional measurement and observation. If you happen to have a tape measure, you can measure the circumference of the tree, and this provides additional information for people who want to know the size of the tree that you're measuring. So now, once you do that, your observation is complete. And then also, here's a couple more slides on accuracy and improving accuracy, and some of the logistical information about it. So once you take your first observation, you will earn a digital tree observer badge. So congratulations. What I'm going to do here is I'm going to show you how to take an actual tree height observation. This is one that I did last spring to do some testing out. But I wanted to show you this because it basically goes through everything you have to do. So if you go in here to the trees tool and you click on New Trees Observation. So once you're into the trees tool, the local date and time of the observation will show up. And then we want to know what the local service conditions are at the time you're taking your tree height observation. So we really want to know those service conditions, because understanding what's happening in the local environment when you're taking these observations of tree height helps us to better understand, what's going on in that area. So snow and ice, is it standing water? Is it muddy, dry ground? Do the trees have leaves? And is it raining or snowing? So now once you do that, you're ready to measure the tree base. So what's going to happen here is when you click measure tree base, your camera will open up and you can angle it towards the tree using this dotted line. So here I'm aligning it with the white dotted line to the base of the tree. And just click on the screen, and yes, I like this one. Now I'm going to go to the top of the tree. And it looks like I missed the top of the tree. So we're going to hit no, try again. Now I'm going to try it again, and yes, I like that. So that's going to take you to photograph the tree. And then you center the tree as best you can with your camera and take a picture. Now, after that, you walk to the base of the tree, remember using that natural stride while counting your steps. Also remember that if you are walking uphill or downhill to the base of the tree, what we'd like you to do is use a tape measure and actually measure the distance from where you took the observation to the base of the tree. And you can input that information later, and that'll be coming up here in a second. So here I'm going to enter 31. So here is this box that comes up that gives you the latitude and longitude, but then also there's a map at the bottom where the red arrow shows you where the app thinks the tree is. And if it looks correct, keep it as it is. If it looks like it's off a little bit, you can actually put 2 fingers on the map to move the map around to align the red arrow to exactly where the tree is. So I'm going to just show you here how you can just move that around and put it in the exact location of the tree you just observed. Once you do that, you hit set position, and then the box will come up that you can enter an optional tree circumference. And I decided to do that. So as I'm doing that, I'm taking the tape measure and I'm putting it around the tree at about 4 feet 5 inches high from the ground. And then once you get that info, once you get that measurement done, you can enter it into, and then after that, what you get is this review box, and gives you the camera height, the stride length, number of steps, distance to the tree, and then in the yellow shaded area, it gives you the calculated tree height. And if you happen to do circumference, shows that as well. We also have a comment box down here where you can add any metadata or other information about the area where you're measuring the tree. If you happen to know the tree genus and species, that would be great. If you want to mention anything about the weather or something you saw around the tree, that's fine. If you happen to see that the tree is dying or the tree looks healthy, you can put that information in there as well. If you see that the tree is about to fall, you might want to put that information as well. Now, if you don't like some of the numbers in there, you can click the little edit button that was at the top right, and you can change this information. Here, where it says distance to tree, is where you can put the actual distance to the tree that you may have measured if you had to walk upslope or downslope to the base of the tree. Because when you walk on a flat surface, it's a little different because you can use that normal stride. So once you do that, once you like all the info, which here you'll see that I didn't put in the correct circumference, it was actually 72.5. So I changed that, and once I did that, I hit complete, and then I can send all my observations. I review the information, and I did that, and I can send it. So I can click right here on the date and time of the one, and then I can send it to the Globe program. Once that processes, your information will be sent for review and then into the Globe database. I hope this helped out a little bit. And, happy tree height observation taking. It's really fun to do, really easy to do. And, once you get used to it, you're going to be able to, take these tree height observations in such a short amount of time. And we want you to get as many trees as possible, especially during, the Trees 2020 challenge. So that said success. So my information has been sent to the Globe database. Thank you, and hope you have fun using the NASA Globe Observer Trees tool. One thing I wanted to also quickly mention is the Trees Around the Globe Student Research Campaign. This campaign, which is in year 2, started at the launch of the ICESat-2 satellite on September 15th, 2018. This is a very cool campaign because it focuses on tree height, and it has students collecting tree height observations as well as using their data from other students, and data from citizen scientists to help develop and complete student research projects. Tree height is a primary indicator of how well an ecosystem can grow trees. Tree height is the main measurement and observation for this campaign, but we also have the students work with other measurements like land cover and green up, green down, or greenings, but then also all the other environmental measurements like air temperature and surface temperature and soil moisture and precipitation and cloud cover, all these things, because we want to know what's happening in the local environment when you're taking a tree height observation. So I want to quickly point something out here as part of the campaign is called an intensive observation period. And these are focused periods of time where participants are encouraged to collect large amounts of data and enter it into the Globe database. This April, during the Trees Challenge in 2020, we will also be having a campaign tree height IOP, or intensive observation period, where students are going to also be taking lots of tree height observations during this time. A lot of them will be using some ground-based instruments called handheld clinometers. Some will also be using the app, the NASA Globe Observer app Trees tool. So we wanted to combine the challenge with the IOP so we get as much data as possible in this short amount of time during the month of April 2020. So if you're interested in this campaign, you can check it out. The campaign URL, as you can see, it's up here at the top of the screen. But as you're copying that, I also want to mention that we have some really good information on here. We have monthly webinars. We have easy get started guide of how to get started with the campaign. So if you know of teachers and students who might want to become involved with this, please direct them to this webpage. And there's contact information under the campaign community section with our team and some of all the other members that are active in the campaign. So this is great. You get to interact with students and researchers from around the world. So far, we have participants from approximately 50 countries. It's great. It's a great way to use science as that mutual interest, and especially looking at tree height. But I just wanted to show you this Trees Around the Globe Student Research Campaign information. Thank you.
Okay, so next up we have Holli Kohl, who is the project coordinator for Globe Observer, and she is going to talk about Globe teams and how those work with the challenge. As I mentioned at the beginning, there's different ways to participate as individuals, as teams, and as schools. So teams is what Holli's about to explain.
Hi, I'm Holli Kohl. I'm going to share with you how to use the Teams tool during the Trees Challenge. So a Globe team is a group of citizen scientists working together As an organization, teams can be used to set up a competition, coordinate community citizen science efforts, support an educational or corporate initiative, or simply enable a group of people to work together. Teams may include Globe Schools and Globe Observer volunteer scientists. For the Trees Challenge 2020, there are a few reasons you might want to consider setting up a Globe team. A team will help you track the impact from an event or a training at your institution. During that event, you might invite guests to take science home and maintain a connection to your institution by joining your team. Through your team, you will be able to see how many people have joined and how many people are actually participating in citizen science and data collection. The team tool will also allow you to compete in the Trees Challenge against other teams, including other libraries or parks or after-school organizations, so that your community is represented as a whole in the Trees Challenge. You can use the team tool to set up a competition, a little mini competition within the Trees Challenge. For example, last year, the Australia Scouting Organization set up teams for every troop in the country, and then invited those scouts to take land cover observations during a mini competition, which was held concurrently with our global land cover competition. Those scouts were so motivated, it turned out that one of their teams actually ended up winning our global challenge for their region. So you could similarly set up small teams for your community if a small competition would help motivate participants. You can use a team to coordinate volunteer efforts, such as a corporate volunteer program or a family group. The example you see there on the right is a team page for family engagement set up by a church community. Finally, you can use the team tool to invite parents, family, or community to support a school. So if you want to know more about how to create a team, how to manage a team, or join a team, I encourage you to look at our Globe Teams page on the Globe Observer website. The URL is there at the bottom of the slide, but you can find it by going to observer.globe.gov, click on the Do Globe Observer menu, click Do More, and then go to Globe Teams. Some tips for setting up a team for the Trees Challenge. If you decide to set up multiple teams, say to hold a mini competition, try to start each team name with the same string to make it easier to group your teams together. For example, Scouts Australia, and then differentiate with the troop name. It'll make it easier for your participants to find your teams. There are 3 different types of teams: a private team, an open team, and a closed team. A private team means that only the people you invite to join the team are going to be on your team. This would allow you to then be able to track the number of people that you have on the team that have joined because of direct interaction with you. An open team, anyone from anywhere can join. You may choose to have an open team, you just won't know if the people on the team are joining because of something you did. A closed team is a team that no longer allows any members to join. You may want to do that if you want your group to be very contained, such as for a science club or something of that nature. But we recommend a private team. It'll give you the most flexibility and ability to manage your team. We do have posters and handouts as part of the Trees Challenge that you can use to distribute your team name and your invitation referral code to your guests. So they will need that code to join your team if you keep it as a private team. After you create your team, please register with us to participate in the challenge. The registration form is on our challenge page. The URL is there at the bottom of the slide. We simply ask for your team name, the type of group you are, and your contact information so we can follow up with you if necessary. Thank you.
Okay, so that is a little bit about how to use Teams. We've got more information on our website, and I know we're throwing a whole lot of information out at you, so there's a lot to cover today, but we have a lot more resources on the website. There's details about the app, the challenge, all sorts of things that are available, and what's actually up next is Heather Mortimer, who's a graphic designer and writer on our team, and she is going to walk you through some key parts of the website and the Trees Toolkit, and some of the things that that are available there. I will also point out that the great artwork that you see related to the challenge, the posters and flyers that she's going to show you, that logo that was part of the introduction, those are all Heather's work, beautiful work. So we really appreciate her having on board, making our stuff look beautiful. So here's Heather.
Hi, my name is Heather Mortimer, and I'll be telling you a bit about how to build and promote your trees programming using our toolkit for informal educators. I'll start by showing you how to navigate the toolkit. Then I'll share a few examples of the different resources that are available within the toolkit. And finally, I'll wrap up by talking about some of the ways that you can connect the Globe Observer app to topics that your community is concerned about. The toolkit is available on the Globe Observer website, and you can navigate to it under the Lead a Program tab. The resources within the toolkit are organized by protocol and resource type. So let's take a quick tour of the toolkit. From the landing page, you can navigate to a particular protocol or scroll down for advanced topics. So let's go ahead and check out the Trees toolkit. If you scroll down to the bottom of the Trees toolkit page, you can see that there are some quick facts as well as tips and troubleshooting specifically for informal educators, but we'll be focusing a lot on the resource library pages. The resources are organized by resource type, so here's the activities page. The next page is books, videos, and presentations. Our book lists are on WorldCat, so you can find the links to the kids and adults list there. And you can also jump down to a section using the navigation at the top so that you don't have to scroll all the way down. And finally, we have our printables and promotional materials. Next, I want to share some examples of different resources that are available within the toolkit. The first is a relatively new activity that uses Legos or other blocks to demonstrate the different ways that satellites collect data. If you look towards the top of this image, the green and blue model represents 2D data collected by Landsat 8. Landsat basically takes photos of Earth from space, similar to how you would take photos with your phone. This data is especially useful for studying forest extent, or how much of the planet is covered by forests. The second model, towards the bottom of the image, represents 3D data collected by ISAT-2. ISAT-2 uses a laser to collect elevation data in narrow paths. As the satellite continues to orbit the Earth, it eventually builds a 3D image. Together, these two types of data can help scientists better understand the total mass of the forest rather than just the height. The paper clinometer is both a printable and an activity. You can build a tool for measuring trees simply using a straw, a weight, string, and a sheet of paper. While looking through the straw, the string indicates the angle at which you're looking at the tree. On the back, there's a worksheet for calculating tree height using this angle. I created a reusable set by laminating the paper and using a dry erase marker as the weight. These are great for comparing to the measurements in the app or leading a program without or with a very limited number of smart devices. We also have an activity in the toolkit that is specifically about comparing between a handheld clinometer and the app. We've built book lists for both kids and adults to make it easy to put together a book display or find a title for a book club. These book lists are accessible from the website and they're built in WorldCat. We used WorldCat because it has features that make it easy to find copies nearby. You can click on View All Editions and Formats to find other languages and versions, and you can also enter your zip code to find copies at nearby libraries. And finally, for the challenge, we've created some promotional materials that you can print and display or hand out. There are quarter-page handouts like the one featured here in both full color and low ink versions, as well as a customizable poster that you can add your team name and referral code to. Here's a brief demo on how to customize the poster. For this, I'm using Acrobat Reader, which is Adobe Acrobat's free program, although you can use any PDF editor. And I'm going to go ahead and open up the poster. We'll want to go over to Tools and click Fill and Sign. And then we'll want to make sure that we have this tool right here highlighted. This is to add text. We'll click right after team name and we'll enter our team name. So for this example, I'm using a team that I created for a different project called Frog Watch Akron Zoo. And I'll go ahead and type it in here. You should also have all this information available to you in an email that you got after you created the team. And I just want to make the text a little bit bigger here so it's nice and easy to see. I'm going to go ahead and move it down to align it nicely. I like it right in the center. And then again, I'll click right after referral code to add a text box. And my referral code is GLID90YI. So I'll type that in there. Of course, this referral code is specific to the Frog Watch Akron Zoo team, so you do not want to use that one. You can find the referral code if you're on the Globe website, just a few lines down from your team name. And I'll go ahead and adjust that to get it aligned nicely. I think that looks good. And next, I just want to point out the checkmark tool right up here at the top. There's also a customizable version of the handout, except there is not enough room for both the team name and the referral code. So you'll want to check a box depending on which one you use. And then, of course, you'll just want to end by saving the file. And then you're all set. So NASA studies trees from a global perspective. For example, the role that trees play in Earth's carbon cycle. However, trees are also connected to local issues from invasive species to public health. People are often concerned about these topics because the impacts are much more tangible. And when people are concerned about an issue, they often want to know what they can do about it. For example, after the park that I worked in experienced its second 1,000-year flood in just a few years, our visitors wanted to know what they could do to help us recover and what they could do to prevent future floods from happening. You can engage your audiences in science that doesn't just help NASA with our global research, but also with a local or regional issue that they're concerned about. You'll want to start by listening. What are your visitors asking about? If you're in a library, are they asking about books on a certain topic? When you're planning your programming, you may want to think about the animals that depend on trees, the threats that trees are facing, and how trees make our cities and communities better. So here are just a few examples of science topics that might be relevant to your site. You can ask, are there invasive species present, like spruce beetle, emerald ash borer, or hemlock woolly adelgid? Have your local forests been impacted by wildfires, disease, or drought? Or are people concerned about animals that depend on trees, like migrating monarchs that depend on the nectar from eucalyptus trees? Have there been any tree plantings or habitat restoration projects that could be monitored using the app? Or do you live in an area that experiences the urban heat island effect or air pollution, which could be mitigated by trees? If you decide to focus on a local topic, you will probably want to talk to a local expert who can inform the project, do a lecture or other program, and potentially even use the data. First, you might want to look within your own organization. This is a great opportunity to work with someone who you don't typically get to work with. Next, you may want to reach out to either your local or state government organizations, like the Department of the Environment or Forest Service. And finally, students and faculty at nearby universities may be interested in working with you as well. We ask for tree height measurements because this data can help us study the health and mass of forests at a global scale. For local and regional topics, you may wish to collect additional data through another project. For example, we're working with Akron Zoo Frog Watch to collect concurrent observations of mosquitoes using the Mosquito Habitat Mapper tool to help us better understand the relationships between frogs and mosquitoes, which often share similar habitats. For trees, you may be interested in documenting wildlife using iNaturalist, counting birds using eBird, or identifying the trees using LeafSnap. You can also find additional projects using SciStarter's online project finder. Add what you find to your field notes within the app, or simply note that you took a concurrent observation. So if you use LeafSnap to find out that you have an oak, let us know in the field notes section. Researchers can actually pull data on the field notes. So if you're working with a local expert, you'll want to ask how they would like the notes formatted. And finally, here are some online resources that I think are really helpful. Of course, we have our Trees Challenge 2020 page, as well as the Toolkit for Informal Educators, which are both accessible from our website. Here's the link for SciStarter, where you can find other citizen science projects if you'd like to take both tree height measurements and some other type of measurement. And then Thriving Earth Exchange is actually a resource that a colleague recently shared with me for helping to facilitate community-led science investigations. So if you decide on one of those local topics and it works really well for Trees Challenge 2020 and you want to continue it, this might be a really good resource to check out. And then in the next column, I have some different resources that are really useful for adding different visuals to your presentations or your displays and what have you. So first is the NASA Scientific Visualization Studio. A lot of the videos that are in our toolkit came from there, as well as many, many more that are available. And then there's the National Park Service Photo Gallery. That's a really nice resource for finding public domain images. If you go into the image information, which is also where you download it from, you can find out whether or not it's public domain, and you're able to use it. And then I also really like the U.S. Fish and Wildlife Service digital library.
Okay, so we've heard a whole lot of what's available, and then a few examples starting there at the end about how it might be used particularly. So let's get some more practical examples about how to implement the challenge and use the TREES tool in informal education settings. Globe Observer has been partnering with public libraries to engage their communities in citizen science, and two of those libraries are LaSalle Public Library in Illinois and the Los Angeles Public Library. And so we have Brittany Blomquist, who facilitates STEAM programs at LaSalle Public Library and is going to talk a little bit about her ideas for trees-related programming.
Welcome, everyone. My name is Brittany Blomquist. I am the program facilitator at the LaSalle Public Library located in LaSalle, Illinois. I've worked in libraries for over 16 years, with most of my time spent in programming and youth services. It's something I really enjoy and I get really excited about. So today I'd like to share with you my experiences in facilitating Globe Observer programs, as well as a couple of STEAM activity ideas to incorporate in your Tree Challenge 2020 programming. If you have any questions, please feel free to ask them in the chat while we discuss the programs. So my library is located in a low-income rural area, so the programming that we provide typically requires us to work within a minimal budget and requires us to structure our programs so that they're easily accessible by our patrons. And using the Globe Observer in our science programming has allowed us flexibility in both of those areas. And that is what makes implementing the Globe Observer programming so great. It's adaptable to any budget, any type of demographic, and it's really easy to implement to create citizen science programming in your community. So one of the goals that we had in mind when we started our Globe Observer programming was to encourage our program participants to engage in their community as citizen scientists. So with that in mind, as often as possible, of course, weather permitting, we hosted our programs off-site in public areas. That isn't something that you have to do to use the Globe Observer programming, but something that we thought was beneficial in meeting our goals. So some of those areas that you can use for offsite programming might be community parks or green spaces in your community, places like nature preserves or public walking trails. We were very fortunate to have a canal walking trail located just a couple of blocks from our library. So that became the main site for our programming. But we also did walks just within a 2-block radius of our library building, and those were also perfect for hosting our Globe programming. We were able to make many different observations. So you don't have to have a natural area. An area within your community still allows you to make great observations and engage your program participants as citizen scientists. So as the program facilitator, I was the lead for our nature walks. However, this is an area that you can bring in other members of the community to participate and share their knowledge of trees, such as someone from the Department of Natural Resources. Here in Illinois, our Department of Natural Resources actually has extension kits about trees, which can help supplement the observations that you make with the Globe Observer app. You might also be able to bring in someone from a forest preserve, another program facilitator from there, or a naturalist who can also speak about trees as you take your nature walk. Nature walks offer a great opportunity to make Globe observations and incorporate other tree-themed activities. With our nature walks, while we made our observations, we also wanted to include some STEAM activities. That would be science, engineering, technology, art, and math. And I'd like to share a couple of those with you as well. So one of our ideas that we used to incorporate data from our Globe Observer tree observations was to create a Fandex. So that would be kind of creating a series of cards that describe each of the trees that were observed on our walk. And we use cards like this, card-shaped templates. It is important to have a hole punched in your card. It doesn't have to be a card exactly like that. There are many different options out there that are readily available depending on your budget and the time constraints of preparing for your program. These we got pre-cut. They're pretty sturdy, so they were durable for our project. You can also cut those same shapes on die cut machines, or if you have access to a Cricut or some kind of digital cutting machine, you can adapt the shape and size to your specific program needs. There's also different mini note cards that are already on a keyring type binder that are just as useful for the same project. Again, many options out there for your program needs. So what we did was, since our cards were a little tough, we had participants make bark rubbings of the different trees they observed on paper, which we then adhered to the cards. And on the back of the cards, we recorded some of the data from our app observations on the back of the cards so that program participants could keep the data with their tree rubbings. Some of the things we included were the location data from the trees. That data comes up in the app after you take your picture. So you'll do your tree measurement, your tree image, and then it'll give you the location data of the tree. And it's right there to easily record on your Fandex cards as well. If you have a card big enough, or if you're going for a larger size format, you can also incorporate things like the leaves of the trees that you're observing, or have program participants do a quick pencil sketch on the back to depict what the tree looks like then and there, at the same time that they made those bark rubbings. Trees change over time depending on what season it is. They may have leaves, they may not, they may look differently. So having program participants kind of study the shape of the trees and what the trees look like will help them track those changes over time visually, not only through going back and making multiple observations with the app, but also through what their Fandex cards look like at different times. So you might run into a challenge with how do you take all of this stuff and all the supplies for your program to an offsite location to do a nature walk, and how do you manage that? We've worked very well with taking our supplies on clipboards, which has also helped us extend our program. This is actually one that we did for our land cover program. But having a clipboard allows you to easily carry your cards, any paper you might want for rubbings, pencils, chalk, crayons. and also allows you to promote your tree programs further with data pasted on the back of your clipboard. It also allows for you to share information about tree identification and extend that conversation about trees further and encourage people to continue to make observations with the app. We also like to carry with us buckets to keep our supplies in, and this also doubles as a way to extend the accessibility of your program. As a person with a disability, I'm keenly aware of when things are accessible and not accessible, so we try to incorporate that as much into our programming as possible to allow people with all abilities and with any physical limitations the opportunity to fully participate. So having a bucket can also double as a seat if you take your supplies out. Everyone stops to make their tree rubbings and tree observations. Flip your bucket over, and that allows people who do need the opportunity to sit down a chance to take a break while you are out on your nature walk, and they can still fully participate. Another way that we like to extend the data that we've taken on our Globe Observer app is to make gratitude rocks. And again, with similar data that we've collected in making our Fandex cards, such as the latitude and longitude data from the app, depictions of how the tree looks, as well as the season the tree may be in, we paint them on little rocks like this. You can see our latitude, longitude data there. This one also incorporated the season on this fall, and then a picture of the tree as it looks in the fall. And how the gratitude rocks work is that the movement of the rock from place to place is tracked on social media. So that's a great way to engage people who are tech savvy, especially younger children and teens, and promote your program and continue the conversation beyond that single day and single nature walk. So as a rock is found, its picture is taken on and posted on social media, and the location that the rock was found is noted in the description of the picture. And then that person who finds the rock takes that rock and moves it and places it in a different spot to be found. And as time goes by, the rock again is found, recorded, and then moved to a different location. So the data about the trees that are depicted on the rocks continues to move along as people find the rocks. So again, it's a great way to engage program participants, continue that conversation, and encourage people to be citizen scientists in their own community, understand the trees that are there, and understand how they can be part of that, and recording the data to send back to NASA through the Globe Observer app.
It's always excellent to hear how different people are implementing it and things that go beyond what the Globe Observer team had thought of. So we didn't have time to include it today, but we also have a recorded presentation from Vivian Bird at Los Angeles Public Library talking about their trees programs and tips for implementation. And we'll put that up on the website. Plus there's some bonus material from Brittany about those gratitude rocks that'll also be available on our website. We had planned to also have Tasia Owen, who's on our Globe Observer communications team, talk a little bit about how she has used the trees tool with Girl Scouts and their Think Like a Citizen Scientist journey. But I think we've gotten a lot of really good questions in the chat, so we want to make sure that we have time to address those questions. So Tasia's video about Girl Scouts will be posted up on the website so that you can look at that a little bit later if that particular topic is of interest. So we've had a lot of information thrown at you today. We've gotten some good questions. I'm going to pull up a document to start answering those, but please continue to type any of them into the chat, and we'll try to get to as many of them as we can in the next 20 minutes, but a document with all of these questions and answers will be posted with the webinar recording on our Trees Challenge 2020 website, observer.globe.gov/trees-2020. For the questions and answers section, please see the document on the Trees Challenge page on the Globe Observer website, observer.globe.gov/trees2020. Also available there are the extra segments that were not included in today's webinar. Okay, well, thank you everybody so much for joining in, and we will absolutely look forward to seeing lots of tree measurements coming in April, and happy early Earth Day.